The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and welcome to the joint webinar with Marek Brothers. My name is Matthew Londe, and I am a senior technician here at Strucksoft. Shortly, I'm going to hand you over to Paul Godwin, BIM Manager for Marek Brothers for the main event. But we wanted to give you a 2-minute introduction into MWF for those of you who aren't familiar with it. So this is the primary tool Marek Brothers use to model walls and ceilings virtually, as well as manage clash detection and create construction documents. We will also give contact details for both Marek and Strucksoft should you have any questions after the webinar. So what is MWF? Well, it is an extension that runs directly in Revit and recognizes Revit elements as well as their openings. It frames in cold form steel and wood and automates the framing placement in Revit. So the most important element of MWF is to remember that it is template driven. By assigning templates to different wall types, you can apply global changes and manage RFIs much more quickly than manually changing individual elements. This is the power of MWF. You can model a lot of detail with MWF, such as kickers, deflection connectors, and equipment backing. Panel joins can be automated using our auto join tool. So we can select predefined panel joins to assign to different wall types. So joining instances to again automate as much of your framing as possible. We can also model the framing of floors, ceilings, rafters, and trusses. So MWF has a full clash detection capability, which automatically detects MEP clashes with walls, floors, and ceilings. So as you can see the MEP objects here that are penetrating through these walls, MWF will create the opening around those elements and then frame them based on the element that had been penetrating. So MWF also automates the shop drawings, as you can see here, to create construction documentations or construction documents rather, with the bill of material and cut lists, and they're all placed in 2D layout views. And then we can also export all that information directly to a CNC machine. So as you can see here, we have an array of suites or extensions. So there's the Pro Wall, Pro Floor, Pro Truss modules, and then the available extensions that are can be included into those modules. And so without any further ado, I'd like to pass you over to Paul. So Paul is ready to start showing. Take it away, Paul.
All right. Well, my name is Paul Godwin. I'm the BIM Manager for Marek. We are a 77-year-old Division 9 contractor servicing the Texas market with one satellite office in Atlanta. Still not sure how we got to Atlanta, but we're there right now. It says, and I'm here to discuss BIM and Division 9. My title may sound a little cynical, that there's a cover-up or conspiracy to exclude my trade from the process. This may not be entirely accurate, but sometimes it sure feels that way. So I'm here to plead my case as to why Division 9 should be an integral part of the BIM process, and I need to be very persuasive because you will be my judge. I'm going to start out giving a case study of a current project we're on using the typical bidding process. We get this invitation for a beautiful high-end hotel in the Houston area, a very upscale area, and we follow the normal progress. We get our drawings, we do our takeoff, we bid the project, and as luck would have it, we were awarded this project. Now this was a BIM project, and so we were hoping that we'd be involved in the bid process. Unfortunately, that's not how it worked out for this job. We started the standard construction build as you figure it out process. So we'll find the issues that occur, submit RFIs, wait for answers, price changes, wait for approval, get approval after submitting the price 3 or 4 times, and then proceed with the work. And then we do the wash, rinse, repeat method of continuing the process. But like I said, this is the age of BIM. We have the technology. We should be able to avoid the craziness that is the standard process. But unfortunately, we were not included in the BIM execution plan. BIM was being used on this project, but it wasn't part of our contract, and it was already actually underway before we were ever awarded a contract. So we went to the GC and we said, hey guys, you know, we know you're doing BIM on this project. We think we could be an integral part of the team. Here's a price to let us join in and play in the game. GC said, no, you really don't. We really don't need you. Granted, the cost was 0.6% of our total contract price. So being it was such a small number, we went back to them and said, okay, if you don't want to pay for it, why don't you let us just do it for, we'll include it for nothing. We'll go ahead, and they said, no, you know, we just don't see the value. So as a result of not being included, not being able to include our framing, our walls, they modeled all the MEP without us, and we get this. Second floor, almost every main plumbing rack was out of the wall. We had plumbing everywhere, all the way up, out of the wall. Hot water lines running out of the ceiling that didn't take into account our grid and our elevations, the drops in the ceiling, multiple plumbing problems, ceiling height problems. Every room, the mechanical closets had to be shifted 2 inches. Every room in the 12-story building had to be shifted 2 inches for the mechanical closets because the fan coil units wouldn't fit. Had we been involved in the process, that could have been caught. As you can see, we have multiple areas where the penetrations, floor penetrations were wrong. As you can see, there's feet all over this, shoes everywhere. We need to teach our guys to take pictures without getting their feet in it. But plumbing out of the wall, where our framing's going over penetrations in the floor, more plumbing out of the wall, more toes. Once again, our shafts intruding on the penetrations. So all these issues could have been avoided had we been able to play in the game. Currently, the millwork guys having to measure every room because nothing can be created as a standard and used in each room. Everything's going to have to be cut per room because of the amount of changes and movements we had to make in the rooms to make the mechanical and the plumbing work. Our first change order for this project was greater than the price that we submitted to be included in the BIM process. Our anticipated cost will be about 4 or 5 times what we submitted for to be included in the BIM process, and that's just our cost. That doesn't include the cost of all the other trades. Plus, this job is being pushed behind schedule. This is, like I said, it's a 12-story high-end hotel, so every day they lose being opening on time is lost revenue, and owners do not like lost revenue. So what was the value of clashing with no regard to our walls and our ceilings? So why should Division 9 be involved in a BIM process? What do we have to offer? And what is our value? To understand that, you need to understand what our deliverables are and our process. Obviously, being a drywall company, we need to include interior wall framing. We can frame all the walls and ceilings with all the studs, ceiling framing included. Kickers, once again, kickers. The interesting thing about kickers, 4 foot on center running both ways usually. I've had multiple GCs tell me, hey, can you turn the kickers off? Because those are going to be in the way when we start doing coordination. Not quite sure why they want them off during coordination since that's the whole purpose, but we've heard that more than once. Exterior framing, what we've done before is we've color-coded walls with our exterior framing, drop in all the studs, show the difference in gauges when we have to change gauges based on wind loads and corners, headers, jams. We're able to color code that and send it out to our field so they can have a more accurate depiction of what they're doing, and it helps avoid mistakes. We do acoustical ceiling grid, and then we can do MEP penetrations like was shown earlier. This is very valuable for us, and we think for the job. It allows us to get ahead of the game. We can run metal wood framer and it'll do all the penetrations, frame them out as we want to, and we can actually start building priority walls, corridor walls as the MEP guys are fabricating. We're not having to wait on them, and we're not having to go back and create penetrations for them. We can do that as we frame. More penetrations, more shops and penetrations. Just makes the job flow a little faster if we can get out in front rather than our typical process is to build the wall and then actually go back and once the MEP guys get there and then reframe the opening. This keeps us from having to do extra work, and it just puts the job ahead of schedule. We're able to do details. If someone wants to see, okay, how's that slip track going to work? How's this detail going to go? We can build it and submit it. And now our process. So what we do at Marek is generally what we've done to this point is we'll take an architectural model. Now, most architectural models, and no fault to the architect, I'm not here to slam architects, are not actually construction models. They're used for design, development, and they take them to a certain point and then they stop. So the models are not necessarily as you would build it in the field. Walls may not all go to the deck that are supposed to go to the deck. They may not be the right thickness. So we'll take an architectural model and we'll check it first for the tolerances, and we'll set our tolerances. Usually is the minimum of 1/16. We'll set it. And this avoids any rounding issues that would throw our dimensions out. And then we'll modify the property of the wall to allow us to change colors as we make changes so we can keep track of the work we've done. And then we start verifying the accuracy of the model. Is it in the proper location, the properties of the wall correct, the height, the thicknesses. A 3 5/8 wall with 2 layers with 5/8 each side is 4 7/8 inch. Sometimes an architect will just make it 4 inches. So we just go make sure that everything is as it's supposed to be when we build it in the field. So we have the proper dimensions, the proper heights. What happens a lot of times is if you run clash detection with an architectural model that they don't extend the walls to deck, well then they think they don't have any problems. And then you get out there and their deck high walls only went to 6 inches above ceiling in the model. You start running into all kinds of issues when you start framing. So we'll change all that, run everything to the deck, make it the right thickness based on the contract documents, and then we'll use MWF to drop in our framing. Now generally what we do is we only drop in critical framing, jam studs, king studs, headers, corner studs, end studs, these kind of things. We can and do drop in all framing if we have to. We're on a project right now where we're doing LOD 500. We're dropping in every stud, everywhere in the building, and running clash detection while we're doing that, which is kind of an issue because it runs into a lot of clashes that are unnecessary, where we in the field will just move a stud an inch one way or another way to avoid a problem. We're running into clashes all over this building that aren't necessary and aren't important. The main clashes we're concerned about: corner studs, end studs, jam studs, and headers. Here as you see the typical process, we got the wall, we make it ours. You can see the framing as it drops in. We got our top track, headers, jams, that sort of thing. Also, once again, we can drop in all the framing if we need to. Ceiling grid, acoustical ceilings. We use actual grid in most of it. We'll drop in the libraries from the manufacturer, This makes it a much better process than just the normal 4-inch space that we'll put in there to save space. We like to actually drop our grid in, helps with the clash detection. Drywall ceilings we typically leave as a no-fly zone, a 4-inch no-fly zone. It's because the grid in a drywall ceiling can be manipulated and to avoid any issues. So now I'm going to give you a few examples of, hey, this guy says they can do stuff. Can they really do it? Marek, we started off, first job we started off with was a full-blown 100% BIM. We modeled everything. We used a total station to lay it out, but it was the typical backdoor BIM process where we bit off 2D documents. We were modeling as we were building, and it did not go ideally. So I didn't use that as part of my case studies. TCH Maternity in Houston, we developed a coordination model. In the beginning, most of the stuff in Houston and around was just 1 room, 2 rooms, just some areas where there were some issues. So we had sound isolators that we needed to install in a heavy MEP area, and we used BIM to create the isolators, submit it to the sound engineer, have him approve it, and once everything was approved, we went ahead and built it. Saved a lot of time and effort in doing that. Next, the Texas A&M University. This was a acoustical ceiling project. At this point in time, there was no grid. Nobody had a grid library. No one out there had anything, so we created our own families here at Marek and then dropped in all the grid, all the wall angle throughout the project. JCPenney store in Fort Worth came in and said, hey, we're going to model the whole project. Man, we were ecstatic. We were like, that's great. Finally, someone's going to let us get in here and do the whole thing. We get in, we build walls to the deck, we drop in all the framing, we do kickers, we do penetrations, ceiling grid, drywall ceiling grid, we do the whole works, and about halfway through the process, they pulled the plug and said, you know what, we're going to drop the BIM on this project. We're too far along. We don't see that it's going to do any value. So we were a little upset about that. We got some practice in, though. So next is the University of Texas North Ackerman building. And in this was a basement area of a hospital, and they wanted to build it out. But when you went in and you looked up to the deck, you couldn't see the deck. As luck would have it, all the walls were rated and all the walls were supposed to go up 28 foot and seal around all of the existing MEP. Well, that just wasn't going to happen. So we were able to use BIM and metalwood framer to create headers, to create box ceilings, shaft wall ceilings, model all the penetrations to where we could do a false ceiling and nothing had to run to deck. Saved a ton of problems. As you can see, that's the existing MEP. There was no way anything was going to deck on that job. DFW Airport, my favorite project. We're currently remodeling all areas of DFW Airport, and the problem was, how do we get the passengers, how do we keep the people safe as they move from terminal to terminal through this construction? So we proposed that we would make basically a people habit trail. And we started designing this within the BIM. We were coordinating with our Dallas office. BIM is centrally located in Houston for all of our branches. We started coordinating with Dallas, developing a movable, reusable habit trail that had to meet certain design criteria. It had to have air conditioning, it had to have fire sprinkling, it had to have electricity, and it had to be rated. So we were able to create this bouncing between the Houston office, the Dallas office, the architect, which was out of state, coordinating all this, and we came up with the habit trail that is being used all over the DFW airport to keep people safe as we do the remodel. Cook Children's Medical Center in Fort Worth, Texas is an IPD, but we were not involved in that. We're in as a GMP, but we were very excited with this. We were thinking, okay, we're going to be able to model everything. We're going to be in early. We're going to be able to influence the design of the project. We show up to the first meeting and they say, all we want you to do is acoustical ceilings. We're like, are you sure? We have the capability to do it? No, just acoustical ceilings, but you're going to be the gatekeeper of the acoustical ceilings. You're going to create the Revit model for acoustical ceilings. Everything runs through you. All changes run through you. Nothing gets done to the acoustical ceilings once it's signed off on unless it runs through Marek Brothers. We're like, okay, but we really could help you out with the framing. And they're like, no. So we get several months into the project, modeling all the ceilings, and now they've come back and said, hey, you remember that framing that you said you could do and we told you no? Hey, how about if y'all go ahead and do that framing now? So we've jumped in and now we're doing all the framing as well as the ceilings, coordination with the ceilings. So it is a full-blown BIM project now. We're involved in every aspect, and we're involved sitting with the architect, the owners, the general contractors, and all the trades, working through the coordination process just like BIM was meant to. Now, Austin Central Library is the main focus of my case study. It's a 6-story library in Austin, Texas. We had full scope interior framing, exterior framing, ceilings, specialty ceilings, and we modeled strictly critical framing is all we were required to model on this. So as you can see, we have our ceilings, we have our grid. Also, you can see where we left the drywall and specialty ceilings as just a chunk, a space, a 4-inch block. Once again, we don't need to put the framing in as it is fluid and can move. Acoustical ceilings obviously have to keep the 2x2 or 2x4 design. Modeled all floors, interior and exterior. Had some pretty intricate radiuses, intricate ceilings. You see the kickers. They let us keep the kickers in on this project. They actually wanted us to include that in the coordination. Go through this, see all of our ceilings. And then we were included in the clash detection process. As you can see, we ran into quite a few clashes, power conduits running through our headers. We had duct completely obstructing construction of the wall. And this is pretty typical. We'll run into, especially in hospitals and things like that, you'll have a 2-hour wall that's supposed to run to the deck, and you'll have a massive duct running right through the middle of that 2-hour wall, and you have to shaft around it. It's a lot of extra money and a lot of extra time. If we're involved in the coordination process, we're able to avoid these things. Once again, you have a duct and the jam studs, sanitary lines clashing with framing. They don't fit in the wall. Once again, our sanitary lines clashing with framing. And this shows the value of being able to drop the framing in. You can see where your pipes and your clashes are actually hitting the studs. And the thing about metal framing is critical framing has to stay there. It can't move. But a lot of the other framing can be fluid. If you're hitting a corner or something like that, that can't be moved. But if you're hitting a stud in the middle of that wall, generally we can move over and accommodate the MEP items. This is duct colliding with headers and jam studs. Once again, we're hitting jam studs. And that's your pretty typical, what you run into is things that are usually pushed through door headers that it's a perfect place to shove mechanical stuff through, but they don't always take into account that the jam studs have to go to the deck, and we run into this a lot. It's a pretty easy fix in the field if we can identify it beforehand. Once again, conduit. This is the value of dropping in the grid. We're able to see that our main T and the sprinkler lines are on the same line. So we have an issue here. If the grid's not dropped in, you don't see that clash. Once again, those darn jam studs right in the way. Then we get the end studs being hit and more HVAC problems. Now, I know I went through this pretty fast. Sometimes I do talk too fast, but in my closing arguments, what can we do to improve the process? What can we do to make it better for everybody? Well, I'm biased, but I would say include Division 9 in your process. We do bring value. We do have something to offer. Next, bring us in sooner. Typically, drywall guys are brought in after the MEP guys have already been awarded, and they've been usually doing clash detection for a month or so. And then we're brought in under the standard contractual hard bid. We get awarded, and if we're involved in the BIM process, then we're brought in late. Next, clearly define your expectations. We get a lot of projects that we're on that they're not sure what our role is. Our scope is pretty unclear. I got a BIM execution plan the other day that the level of development was called medium. I don't know that they'd heard of LOD through 500. They just said LOD medium. We weren't sure quite what that meant. So clearly define your expectations, what we can do for you, how we can help the process. That'll help everybody in the long run. Next, know what you need versus what you want. First job we got with a big contractor in Dallas, I sent our list of deliverables to our project manager. I said, do not send this to the GC just asking what he needs. Well, as a good project manager, he just forwarded right that along, and the GC said, we want it all. And we were like, well, what do you need? Well, we want it all, but you don't need all this. So once we got in and had conversations, and lengthy conversations, I might add, we were able to determine you don't really need all that. You just need, like I said, most of the time, critical framing. We're on a project right now, LOD 500. I don't think the GC really understands what LOD 500 is, but every question I've asked, why do you need it done this way? It's not really critical. It has nothing to do with clash detection. The response is always LOD 500. And like I said, I do not think it means what he thinks it means. But we're working with him. We're giving him what he wants. And in the end, we'll have a beautiful, completely framed model showing exactly how we're going to build this project. I'm not sure what will be done with it, but it'll look really good. Next, stick with the plan. A lot of times, as I've talked about, we'll be in the middle of the process and they'll just dump the BIM plan altogether. We've been in the middle of the process and then been excluded part of the way through. Said, you know, hey, we appreciate it, but we're going to go ahead and keep coordinating, but we're going to coordinate without you. Usually that's when an MEP sub is running, and nothing against MEP guys, they've been doing this a lot longer than we have. They're used to having a certain amount of anonymity when it comes to BIM, and then when you start sticking studs and stuff in their way, they don't always like it. And we've been on a couple projects where the MEP guys were the gatekeeper, and about halfway through the process they just say, hey guys, we appreciate what you've done so far, but we're going to continue without you. If we're part of the process, man, stick with the plan, let us keep going. And finally, treat us as an equal partner. You know, we have 6 full-time modelers that work for us. They work hard, they've trained, they put their time and effort into this, and the reality is that many times we have to fight to get our clashes including coordination. We'll sit through 2-hour meetings and we'll have to say, hey, wait, you know, they're concluding the meeting. We're like, hey, wait, you know, we've got some clashes we need to go through. So just if we're involved, treat us as a equal partner, and I think that'll help the BIM process go just fine. So if you just implement these few recommendations, I think Division 9 can impact the overall project positively and avoid many of the pitfalls of the standard construction methods. And in the case for Division 9, I rest my case.
Great, thanks very much, Paul. Just to let everybody know, a email will be sent out with a recording of today's webinar, along with all of our contact information. So if any of you had any questions you had for either Paul over at Marek Brothers or for anybody here at Strucksoft regarding the MWF software, that contact information will be in there.